Okay, so these are the same hints that were on the board in class today. So remember, when you have a line and it's already in the correct form, y equals negative 4x minus 3, that's in the correct slope-intercept form, then you're ready to go. You just take the scale factor and multiply it by the y-intercept. So the final answer would be negative 4x plus 6, because 3 times 2 is 6. You do not ever change the slope. That stays the same all the time, because you don't want to change how steep it is. You just want to change how far away and where it hits the y-intercept. So multiply the scale factor by the y-intercept. Number 2 is the same idea, except the line that they give you to start off with is not in the correct form. So the work I'm showing you there, that was on the board in class, is just me rearranging the line to put it in y equals mx plus b form. So this is just the same line as that they gave me, but it's in y equals form. So then you take the scale factor and multiply it by the y-intercept, and that is my final answer. Y equals negative 1/5 x plus 15. Notice again, the slope never changes, just the y-intercept by the scale factor. Number 3, there's a couple of ways to do this. It's not the shortest way, but it's the easiest to understand. Again, you have to take this line that they gave you and put it in slope-intercept form, which is really just dividing by 4 throughout, which I show right here. So another way to say that line would be y equals negative 5/4 x plus 7/4, which is a little crazy looking, but all you care about is the slope of negative 5/4. Because a dilation is going to have the same slope. So which one of these 4 choices has the same slope, negative 5/4? So you go through each one, and you try to find out which one is going to give you the same slope as negative 5/4. When you get to choice C, and you work on it like this, I'm going to try to solve for y, and I now have negative 5x plus 20. I'm going to divide everything by 4, and you can already see it taking shape there. Choice C is going to end up like this. Negative 5/4 for a slope. So because that's the same slope as the original, then that's the one that was dilated. That's the only answer that has negative 5/4 as a slope. Number 4, and I would use real graph paper for this problem. I did a really neat job because I had the iPad. I wouldn't expect you to graph this accurately by making your own grid. So you'll have graph paper available to you if you needed it, or ask me for it and I will give it to you. You graph the line, which is already in y equals mx plus b form. The y-intercept is negative 9 and the slope is up 4/1. So I put the y-intercept at negative 9, and then I went up 4/1, up 4/1, and I drew my line. It just so happens that the center of dilation that they told me about, 2, negative 1, happens to be a point right on the line. So if the center of dilation is on the line, then the answer doesn't change. The line stays the same. Once the center of dilation is off of the line moves. But if the center of dilation is on the line, and again, it is right here at 2, negative 1, then the answer remains the same. Number 5, very important that you understand image over pre-image is what a scale factor really is. So any part of an image divided by any corresponding pre-image. So they tell you in the problem that CD is the image, which means that's the image right there, and that was the pre-image. So this one got smaller, it shrunk, it got dilated by a fraction of some sort, but it just wants to know the scale factor, and there's no numbers, so you have to use side names. There are 3 different ways you could state the scale factor. You could say image over pre-image, CD over AB, but that's not a choice. You could say EC over EA, but that's not a choice. Or you could say ED over EB, and that is a choice. So you can almost see that they're triangles. Once you draw the lines of dilation in, you almost have, you can see there's a triangle there, and then you can also see that there's a big triangle on the outside. So which small side divided by which big side is shown down here? And it ends up being this one, ED over EB. That's the scale factor. Number 6. To find the center of dilation, and in all honesty, this graph was a little bit hard to read, and that wouldn't happen on a quiz, but the idea is to connect your C's. I'll do it again so you can see it. You connect your two C's, you connect your two B's, B and B prime, and you connect your two D's, your D and D prime, and they meet at the center of dilation. They'll always meet at the same spot. In this case, if that's the origin, then it's -4, 0. Now the scale factor, once you have the lines of dilation in, from the center of dilation to the original B, looked like it went up 2. To the dilated part, it goes up 6. So if it went from 2 to 6, then it tripled. It's now 3 times as far. 6B, start off the same way. Connect your B's together. Connect your D's together. Connect your C's together. And again, a little bit hard to read, but you can tell that it's over 4, up 4. So the point that it meets at is 4, 4. And the scale factor from here to the original, and then from here to here, without even counting boxes, you can tell that that was cut exactly in half. But if you wanted to count boxes to any of these points, you could say that the original was over 4 down 2, so just go over 2 and down 1. And those numbers are half. So this was cut in half because the primes were actually smaller than the originals. Number 7 we did in class. All 3 classes today we did this together.